Let's consider problem number 1. A W14 by 550 is used as a column to carry an axial load of 3,600 kilonewton. So meron tayong value ng P natin na applied dito sa column natin, which is equal to 3,600 kilonewton. Design a square base plate to support the column. So, meron tayong value ng base plate natin dito. So, let's say it is a square base plate, meaning to say, parehas lang yung dimension natin. So, kung n yung value natin dito, definitely yung value ng b natin dito is equal to the dimension natin dito na n. So, hahanapin natin yung value ng dimension ng mga base plate natin. Considering that it is a square base plate. The base plate rests on full area of a square concrete compression block with F prime C is equals to 21 megapascal. So, sinabi dito sa problem natin, yung A1 natin, which is yung dimension ng base plate natin, covered niya yung entire area ng concrete compression block natin. So, the value of your A1 is equal to A2. So, yung first step natin dito is indicate muna natin yung column load natin. So, the value ng column load natin as stated dito sa problem natin is equal to 3,600 kilonewton. Then, after considering yung column load natin, hanapin naman natin yung value ng allowable bearing stress natin. So, for this one, solve natin yung allowable bearing stress dito sa concrete natin. So, since yung value na yung dimension ng base plate natin is kinover niya etong sa concrete natin, so the value of your allowable is equal to 0.35 F prime C. So that is equal to 0.35 multiplied by 21. So the value of your FP is now equal to 7.35 megapascal. So in designing for the area of your of your base plate or the value of your A sub 1, so lagi nating ginagamit dyan yung value ng allowable bearing stress natin. So for that will become yung column load natin all over the allowable bearing stress on the concrete. So that is equal to 3,600, so times 10 raised to 3 para maging Newton all over yung 7.35 natin. So that is Newton per mm squared. So the value of your area 1 or the value of your column base plate is equal to 489,796 mm squared. So since sinabi dito sa problem natin that it is a square base plate, so equate lang natin yan sa n squared or n multiplied by n. So the value of your n is now equal to, so approximately that is equal to 700 mm. So since nakuha na natin yung value ng n natin, siyempre i-design na rin natin yung thickness ng base plate natin. So, yung dimension natin, that would become 700 by 700. Pero, meron pa tayong kulang. What is the thickness of your column base plate? So, para mahanap natin yon, so, remembering yung formula natin for the plate thickness, that is equal to T is equals to square root of 3 yung actual bearing stress natin sa concrete, x squared all over FP. So, kailangan muna nating malaman yung value ng X, value ng actual bearing pressure, and yung FB natin that is given na 0.75 Fy. So, kunin muna natin yung value ng X natin. So, to find for the value of your X, so hahanapin muna natin yung value ng M natin at saka yung value ng N. Yung M at saka yung N. So, para mahanap natin yan, so gagawin natin is kukunin muna natin yung critical section natin. So, for this part, hanapin muna natin yung height natin dito, which is equal to 0.95 of D. So, 0.95 of D or 0.95 of 437. Yung 437 natin, that is yung depth ng W14 by 515. And at the same time, yung 514, that is the base of the flange ng W14 by 550 na column natin. So, yung value natin dito na 0.95 of D, that is equal to 415.15. And at the same time, the value of your 0.80 BF, that is equal to 411.2 mm. So, hanapin na natin yung value ng M natin at saka yung value ng N natin. So, the value of your M is equals to, so yung buo natin, which is equal to 700, minus the value of your 0.95D, which is equal to 415.15. Since dalawa yan, i-divide natin yung M natin sa dalawa. So, we will now have the value of your M, which is equal to 142.425 mm. Next naman is hanapin natin yung value ng N natin. So, that is equal to 700 minus yung 0.80 BF natin na 411.2. I-divide natin by 2 to solve for the value of your N, which is equal to 144.4 mm. Therefore, the value of your X, yung larger between them. So, it is obvious na yung N natin, yung nag-govern sa dalawa. So, kasi ito yung mas mataas na value. So, adapt natin yung X natin, which is equal to 144.4 mm. So, yung hahanapin pa natin dito is the value of your actual bearing pressure or the value of your FP. So, FP, that is equal siya sa yung P natin o yung column load all over the area actual. So, yung column load natin, that is equal to 3,600 kN all over yung area natin na actual, which is equal to 700 squared. So, the value of your FP is equal to 7.347 megapascal. So, substitute natin yung mga values natin dito sa formula natin to solve for the thickness. So, that is square root of, so 3 multiplied by 7.347 multiplied by 144.4 squared natin all over yung FB natin, that is 0.75 of Fy. So, yung Fy natin, that is, since it is 836, that is equal to 248. So, 0.75 by 248 megapascal. So, you will have 186 megapascal. megapascal. So this is equal to 0.75 of 248 since 836 yung given natin sa problem. As indicated dito, use 836 base plate. So, we can now calculate for the value of your plate thickness, which is equal to 49.71 mm or say 50 mm. So, yung the design natin na base plate, that is equal to 700 mm by 700 mm by 50 mm thickness of base plate. So, ito yung na-design natin na base plate. Dito sa W14 by 550 natin, na ipapatong natin sa concrete compression block na with F prime C, which is equal to 21 megapascal.